going to go on and talk about decimals and rounding. When we're talking about decimals and rounding, it's important to know your place values. So let's say we have the number 5.67158. Well, the 6 here is in the tenths place with a TH. Not the tens place, but the tenths place. And then the hundredths place, the thousandths place, and then so on. So the next one would be the 10,000ths place and the 100,000ths place. So if we're asked to round to the hundredths place, then we're being asked to round to 2 decimal places. If we're asked to round to the tenths place, we're being asked to round to the first decimal place, and so on. I think the reason why that's hard for people to remember is they want to start counting with 1, but there's no once place. I don't know how to spell it because it's not a real word, but there's no once place. If you think about these numbers here, when you're doing your decimal place values, you're essentially saying the size of the denominator if I converted that to a fraction. So to put a 6 in the tenths place is to say you have 6 tenths. To put a 7 in the hundredths place is to say you have 7 hundredths, and so on. If we had a once place, like let's say the 6 was in the oneths place, that would be 6 over 1, which isn't a fraction, it's a whole number. So it just doesn't make any sense for there to be a once place. I don't know if that's helpful for keeping track of why you start with the tenths place in the decimal land, but that's the reason why, more or less. So now we're going to change gears and talk about the rounding rule. So the rule is more or less if the digit after the place you're rounding to is 5 or greater, you increase the value of the digit you are rounding to by 1. If the digit after the place you're rounding to is less than 5, leave the value of the digit you are rounding to the same. That's a mouthful and somewhat confusing even to me, and I know how to round. So let's look at it in an actual example to see how this plays out. Alright, so let's round the number we looked at before to the tenths place, 5.67158. So the tenths place is the 6. So our rule says that the thing that's going to boss us around is the number after that, or the number to the right of that. So whatever place you're looking at, the thing that makes the decision is the guy after that. So here that's a 7. 7 is greater than 5. So that means we're going to increase the 6 up to a 7. So when we round this, it's going to become 5.7. So the 7 was greater than 5, which bumps the 6 to a 7. The thing that's making the decision is not the number that you're actually going to change or keep the same. That's the important thing to keep in mind. Okay, let's do the same thing with a slightly different number. Now we're going to round 5.63178 to the tenths place. The tenths place is still the first digit after the decimal. The thing making the decision here is going to be the 3. Now the 3 is less than 5, so that means we're going to leave the 6 alone. So this number rounded to the nearest tenths is 5.6. There's some confusion about when you make the number smaller. When you're rounding, you never make the number that you're going to smaller. It either goes up by 1 or it stays the same. So if you think about it, let me get myself some room. Alright, so I've got the 2 numbers we've rounded so far and what they rounded to. Now what I was going to say is if you think about it, when we're trying to round to the tenths place, the number that's making the decision and the number that we're thinking about changing. I want to look at those, and I just want to pull them out of the number, and this is to kind of understand what we mean by round to the nearest tenth. Well, if we think of those 2 numbers, if I think of 67, then the question is that closer to 60 or is that closer to 70? Well, that's closer to 70, so essentially I change those 2 numbers into a 70, but then I don't keep the 0 because I'm rounding to the nearest tenths place, so I stop at tens. Whereas down here I have a 63, and I'm asking myself, is that closer to a 60 or is that closer to a 70? Well, 63 is closer to a 60, so essentially I'm changing those 2 digits into a 60, but I'm dropping the 0 because it's unnecessary in decimal land, and we're asked to round to the tenths place. So that's the idea when we talk about rounding to the nearest. That's what's going on. And so if you think about it in terms of that, you're never going to drop down to, say, in this case, a 50. That's never going to be closer. Hopefully that helps you understand why it is we're never going to drop the digit by 1. We either increase it by 1 or we keep it the same. Okay, let's look at a couple of cases that I think are a little trickier for people, and then I will be done rattling at you about rounding. Alright, I changed the direction slightly. I changed it to round to 2 decimal places, so I'm not talking about it in terms of place value anymore. This makes it a little easier to understand. But we're rounding to 2 decimal places, so we want our number when we're done to have 2 decimal place values, which means we're asking what's going to happen to the 9, and the 7 is making the decision. Well, 7 is bigger than 5, so it's going to bump the 9 up 1. Now when you bump it up 1, well, 9 goes to 10. And so what that looks like is, like, you can't put a 10 in one digit, and so the 1 of the 10 is going to bump up another digit. So what you end up getting is 2.4, because the 7 bumps the 9 up 1, and that goes to a 10, and that 1 of the 10 bumps the 3 up 1. But then technically you should also keep the 0 of the 10 in the second decimal place, and the reason why is because we're rounding to 2 decimal places. Some people will pick on you about that, especially scientists, and some people won't, but technically if you're rounding to 2 decimal places, this would round to 2.40. So that one's kind of a tricky one. I wanted to throw out one more tricky one. It's not really tricky, it's just kind of this nuance in math that can be kind of annoying. So let's say we have 3.141414, and the 14 is going to repeat forever. Now, one of the things that a lot of people seem to hang on to in their math learning is we can use math shorthand and make that 3.14, put a bar over it to indicate the repeating. So that bar says that we're going to repeat whatever's under it indefinitely, forever, to infinity. Okay. Now, our job here is to round to 2 decimal places, and that has 2 decimal places, but that technically is not rounded to 2 decimal places because that is repeating forever. It's just using shorthand to indicate the repeating. To round to 2 decimal places, you would actually have to write it without the bar. Now, that seems picky, but let me give you another one to explain why it actually turns out to be somewhat of a big deal. Let's say we have 3.676767 and so on for the rest of our lives and beyond. Then if I wrote that with the repeating bar, that would be 3.67 with the repeating bar over it. But if I rounded it to 2 decimal places, it would be 3.68 because we're rounding to 2 decimal places, which means this is the place value I'm rounding to, and the 6 is making the decision. The 6 is greater than 5, so it tells me to bump the 7 by 1. So when repeating bars are great, especially if you want to indicate the full value of a repeating decimal. I think they're great because it's more accurate than rounding. But it is not something that's used within rounding. For rounding, you actually have to decide to truncate the number and how to do it in a mathematically decided on manner of which tens is closer, in this case hundredths is closer to the original number, or which one the original number is closer to. I guess you could say it either way. So anyways, just that little nuance that has caused students to be wrong and they don't know why they're wrong is that repeating bar is not used within rounding notation. Hopefully you find this helpful. Go ahead and try some problems and see how you fare.